Hello everyone, my name is Lalit Chauhan and welcome to this YouTube channel Mathletes. So in this YouTube video I'm going to teach you how to solve the questions of number system. So we are going to learn all the basics plus advance of this topic. Now we are going to learn everything that comes under number system and what kind of question comes in SSC CGL exam or any other kind of SSC exam. So we are going to learn everything about number system in these videos. So let us start. So number system is I basically categorize this number system into three major parts. So first of all, the first part that I categorize number system into is questions based on finding the factors. Questions based on finding the factors. This is the first major part that number system is categorized into. Now I can say the second part is questions based on divisibility. And then the third part in this one is the questions based on finding unit digit and finding the remainders. So these are the three major parts in which a number system is classified into. So slowly and gradually we are going to learn all these three topics and what kind of questions come in the SSC CGL exam or any kind of SSC examination. So we are going to start with the first one, questions based on factors. So the first topic is questions based on finding the factors. Questions based on finding the factors. Now what does this mean? Questions based on finding the factors. This means let us start with an example. I'm taking an example. I'm saying let us say 24 is a number. Let us say 24 is any number. And I have to find that how many factors are there in 24. I have to find the number of factors. I have to find the number of factors in 24. Now what I can do, the simplest way is either I can factorize this 24. How I can do that? I can simply factorize it by writing 24 and then simply finding its factors. Now I can say the factors of 24 are 2. Another factor of 24 is if I multiply this 2 with this 2, I get 4. Similarly, another factor of this is if I multiply this 2 with this 3, I get 6. Then I can also say that another factor is multiplying all these 2's, I get 8. Then multiplying this 2 4 times and then with this 3, I get 12. And then if I multiply all these numbers, then 24 is also the factor of all these numbers. And then there is one factor that is called as 3. And then there is one more factor that is called as 1. Now 1 and the number itself, these are always the factor of any number. 1 and the number itself, these are always the factor of any number. Now other factors are these remaining factors. So I can say there are total of 1, 2, 3, 4, 5, 6, 7 and 8. I can say there are total of 8 factors. There are total of 8 factors in 24. Now what is the way of or what is the short method of finding the number of factors? As if the number is bigger than 24, let us say the number is of 3 digits or 4 digits, every time it is not possible to factorize the number like this and then finding the number of factors. So the way of finding the number of factors is, just see this very carefully. What I can do is I can write this one as 2 raised to the power 0. Similarly, I can write this 2 as 2 raised to the power 1. then I can write this 4 as 2 raised to the power 2. I can write this, I can also write this one can be written in two ways. Either I can write 2 raised to the power 0, or I can write 3 raised to the power 0. I can also write this number as 3 raised to the power 0. Now, and then I can write this 3 as 3 raised to the power 1. So there are plenty of ways of writing these numbers. Either I can write 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 3 raised to the power 0, 3 raised to the power 1. Now I have written these 5 factors like this. Now what about the remaining factors? Like this 6, and then now I can also write this 8 as 2 raised to the power 3. So I have written all these numbers like this. So what I can do, I can arrange them like this: 2 raised to the power 0 plus 2 raised to the power 1 plus 2 raised to the power 2 plus 2 raised to the power 3. And then remaining numbers I can write them like this: 3 raised to the power 0 plus 3 raised to the power 1. Now what I can do is, if I multiply all of them, like if I take any number from here and if I multiply this number with all these 2's, if I take this number and I multiply with all these 2's, so what I will get is, I will get all of these factors. So what I can say, if I multiply them, I am writing it. If I am writing this 2 raised to the power 0, I can write it as 1 plus 2 plus 4 plus 8, and then writing this one as 1 plus 3. Now multiplying all of them, how I can write them? If I multiply this one with all of these factors, I can write them as 1 plus 2 plus 4 plus 8. Similarly, multiplying this 3 with all these factors, I can write them as plus 3 plus 6 plus 12 plus 3 8 24. This is how I can write them. Now as you can see, I got 8 factors from here: 1 2 3 4 5 6 7 and 8. So how I got these 8? I got 4 factors from here, I got 2 factors from here, and then I can say 4 multiplied by 2 gives us 8. Let us see another question in this. For example, let us say I am talking about 36. Let us say there is a number that is 36. Now if I have to find the number of factors in this, what I can do? I can see how many, or I can factorize this 36. I can write this one as now this number can be written as 2 raised to the power 2 multiplied by 3 raised to the power 2. Now this is how I can write this number: 2 raised to the power 2 multiplied by 3 raised to the power 2. Now what is the way of doing this? The way of doing this is, if I can write this number as 2 raised to the power 0 plus 2 raised to the power 1 plus 2 raised to the power 2. Similarly, I can write this 3 raised to the power 2 as 3 raised to the power 0 plus 3 raised to the power 1 plus 3 raised to the power 2, as I told you in the previous question or in the previous example. Now if you see this, I got 3 factors from here, I got 3 factors from here, and if I multiply them, I can say total there are 9 factors. I can say total there are 9 factors of this number 36. Now how do we reach this conclusion? You don't have to do this every time. What you have to do is, you just have to see the powers on the numbers given to us. You can see 2 raised to the power 2 multiplied by 3 raised to the power 2. Now whatever the powers are, you just add 1 in them. I can write this 2 as 2 plus 1. I can write this 2 as 2 plus 1, and then simply multiplying them, I can say the number of factors are 9. So in short, I can say if a number is of the form a raised to the power p, b raised to the power q, then the number of factors are p plus 1 multiplied with q plus 1. This is how we get the factors of any kind of numbers. Now what is a and b here? A and b are the prime numbers. A and b are the prime numbers over here. Now what are prime numbers? Prime numbers are the numbers which are only divisible by 1 and the number itself. So whenever you factorize any number, you will always get a prime number. Remember this. I'm again saying this. Whenever you factorize any number, you will always get the prime numbers, and you have to write it like this. Let us take one more example in this. Let us take another example. The question is, we have to find the number of factors in this number 1080. Now how we can find the factors? Again, you just have to factorize it with the smallest numbers possible. Like I can say 2 raised to the power 2 540 times, then this is 270 times, then this is 390, this is 330 times, 310 times, then this is 2 5 times, and then this is 5 1 time. So I can write this number as 2 is appearing how many times? 2 is appearing 1 2 3 times, that is 2 raised to the power 3. Now 3 is appearing 3 times, that is 3 raised to the power 3, and 5 is only appearing 1 time, so 5 raised to the power 1. Now as you can see that 2, 3 and 5, all of these are prime numbers. So we can say that every number is made up of prime numbers. If you are going to factorize it, you will always get the prime numbers. So what is the way? You just add 1 in the powers. So this is 3 plus 1. Adding 1 in this one, this is 3 plus 1. And adding 1 in this, we will get 1 plus 1. So this is 4 multiply 4 multiply 2. So we can say there are total 32 factors of this number. We can simply say that there are 32 factors of this number. So this is how we find the number of factors of any kind of number. How do we find the number of even factors? Now again, I am taking the similar example that we took earlier. Let us take the example of that number, that is 24. Now if you factorize this number, I can write this one as I can say that this is 2 raised to the power 3 into 3 raised to the power 1. Now again, as I told you that how can we write this number? I can write this 2 raised to the power 3 as 2 raised to the power 0, 2 raised to the power 1, then 2 and then 3. Similarly, I can also write this 3 raised to the power 1 as 3 raised to the power 0 plus 3 raised to the power 1. Now, how do we get the even factors? Now, even factors, we get even factors when we eliminate 1 from the powers of 2. Wherever you see 2, wherever we get this 2, now as you can see this 2 raised to the power 0 will give us 1, and when this 1 will get multiplied with 3 raised to the power 0 and 3 raised to the power 1, you will always get the odd factors, but we have to only find the even factors. As we know that any power of 2, if multiplied with any odd number, we will always get an even number. We will always get an even number. So if I multiply odd with odd numbers, we will always get an odd number. So what we have to do, whenever we have to find the number of even factors, we just simply have to eliminate this 2 raised to the power 0. What does this mean? Again say this. Now the question is 2 raised to the power 3 into 3 raised to the power 1. What I am saying is, whatever power of 2 we have, we just have to write it as it is, and then we have to add 1 in the another powers. Like this is 1, I can write this one as 1 plus 1. So this is equal to 3 multiplied 2, that is 6. So I can say that there are 6 even factors of 24. Let us take this number 36. Suppose I have to find the number of even factors in this. I have to find the number of even factors in this. Now how I can find the number of even factors? Again same thing. First of all, I have to factorize it. I can write this one as now what you have to remember is, as I have told you, that 2 raised to the power 0 always gives us 1, and when this 1 gets multiplied with this 3, it will always gives us an odd number. So what we have to do, we always have to eliminate this 2 raised to the power 0. So eliminating this 2 raised to the power 0, you have to write this power as it is 2, and then whatever remaining powers are there, you just have to add 1 in them. So I can write this one as 2 plus 1, so this will be equal to 6. So I can say that there are 6 even factors of 36. Let us take one more example in this one. Suppose I am saying, let us say there is a number 1080, and I have to again find the even number of factors in this. So again factorizing this number, I can write this one as now again for finding the number of even factors, you just keep this power as it is and then adding 1 in the remaining powers. This will be 3 plus 1, that is 4, and this will be 1 plus 1, that is 2. So the answer will be 24. I can say there are 24 even factors of 1080. So this is how we find the number of even factors. If any question comes, you just have to eliminate 2 raised to the power 0, and then you have to add 1 in the remaining powers. Now the third topic that comes in this one is finding the number of odd factors. Finding the number of odd factors. Now how do we find the number of odd factors for any number? Again, I am taking the example of 24. If you remember, we got the factors of 24 as 2 raised to the power 3 into 3 raised to the power 1. Now again I am writing this 2 raised to the power 3 as writing all its possible powers. Similarly, writing this 3 raised to the power 1 as 3 raised to the power 0 plus 3 raised to the power 1. Now as we know that for finding the odd number of factors, we have to eliminate all the 2's. We have to eliminate all the 2's. Now why we have to do that? Because if 2 multiplied with an odd number will always gives an even number. As we have to find the odd factors, so I have to eliminate all the 2's, all the factors of 2. Now what we can see here, that we have 4 factors over here. So I have to eliminate all of them. If I have to eliminate all of them, then we just have to see the remaining factors. Now you can see that there are 2 factors of 3. As there are 2 factors of 3, so I can simply say that there are 2 odd factors. There are 2 odd factors. Now how do we actually solve this question? If the number is large, so every time you don't have to do this. So how do we actually find the number of odd factors? What you have to do, as the factors of this number is 2 raised to the power 3 into 3 raised to the power 1, you simply have to eliminate all the 2's. Just eliminate all the 2's, and then whatever powers are there, just add 1 in it. So I can say 1 plus 1 is equal to 2. This is how we get the number of odd factors. Let us take another example in this. I am taking this example again, and let us find the number of odd factors in 36. How many odd factors are there in 36? Again I am factorizing this. I can write this one as I can write this one as 2 raised to the power 2 into 3 raised to the power 2. As I have told you that 2 if multiplied with any odd number will always gives us the even factors. So we have to eliminate all the 2's, and whatever powers are there, you just add 1 in it. So 2 plus 1 is equal to 3. So I can say there are 3 odd factors. there are 3 odd factors in this number, that is 36. Let us take one more example in this. Let us take this number 1080. Factorizing this number again and finding the number of odd factors. Now what we have to do, for finding the number of odd factors, we have to eliminate all the 2's from here. Eliminating all the 2's, and whatever remaining powers are there, you just add 1 in them. So what we got here, this 3 plus 1 is 4, this is equal to 2, and 4 multiplied 2 is 8. So I can say there are total 8 factors that are odd in number 1080. So this is how we find the odd number of factors. Now another question that arises in such kind of questions is how to find the sum of all the factors. Finding the sum of all factors. How to find the sum of all the factors. Now again I am taking the example of this small number, that is 24, and I remember that the factors of this number is 2 raised to the power 3 into 3 raised to the power 1. Now expanding this 2 raised to the power 3, I can write this one as writing all the possible powers of this, and the writing this number as 3 raised to the power 0 plus 3 raised to the power 1. So I can write this number as 1. This is equal to 2, this is equal to 4, and this is equal to 8. Similarly, this is equal to 1 and this is equal to 3. Now if I add all of them, I get this number as 15, and if I add this, I get as 4, and if I multiply all of them, I get 60. So I can say the sum of all these numbers or all these factors is 60. That is, whatever factors of 24 are there, the sum of all the factors is equal to 60. So this is how we find the sum of all the factors. If you have to find the number of factors, you simply see that these are 4 factors, these are 2 factors, and 4 factors multiplied by 2 we get as 8 factors. But if we have to find the sum, then you just simply write the respective values of all these factors, simply add them and then multiply them, we get the sum. Let us take another example in this one. Let us talk about this 36. Now this 36 can be written as 9 multiplied by 4, or I can write this one as 2 square multiplied by 3 square. Now again expanding this 2 square, I can write this one as 2 raised to the power 0 up to 2, and then 3 square can be written as 0 and then I can write the respective values of all of them. So I can say if I multiply them, I get the answer as 91. So I can simply say that the sum of all the factors of 36 is 91. So this is how we find the sum of all the factors of any number. You just simply have to write the maximum possible powers of those numbers and then expand them and then simply multiply them. This is how we find the sum of all the factors. Now another topic or another question that can be asked is finding the number of even factors. Finding the number of even factors. Now how do we find the number of even factors? Now the criteria or the method is same. As I have told you, if I take this example again, that is 12 or 24, if I take this example again, The factors of this number are 2 raised to the power 3 into 3 raised to the power 1. Now I told you this, that for finding the number of even factors, we always eliminate 2 raised to the power 0. We have to eliminate this number. That is, I can write this 2 raised to the power 3 as 2 raised to the power 1, 2 plus 3, and then I can write this 3 raised to the power 1 as 3 raised to the power 0 plus 3 raised to the power 1. Now this is how I can write the numbers. Now as we know that 2 if multiplied with any odd number will always gives us an even factor. So what you can do, you can simply write down the respective values of these numbers. This can be written as 4, this can be written as 8. Now I can say that there are the sum of all the even factors of 24 is 56. If you see all the factors of 24 that are even, then the sum will be 56. Let us take one more example in this one. Let us talk about a number that is 36. Again I can write this number as 2 square multiplied by 3 square. Now eliminating 2 raised to the power 0, I can write this one as 2 raised to the power 1, and I can write this one as 3 raised to the power 0, 1 plus 2. Now you only have to eliminate 2 raised to the power 0. We don't have to eliminate 3 raised to the power 0. So this, writing the respective values, we can say this is 2, this is 4, this one is 1 plus 3 plus 9, this is 6, and this is 13. Now 13 6 times is 78. So I can say that the sum of all the even factors of 36 are 78. That is, if you will find the factors of 36 and if you will only add the even factors, then their sum will be 78. Now the fifth heading that comes in this one is finding the number of odd factors. Finding the number of odd factors. Now how do we finding the sum of all the factors, finding the sum of odd factors. Now how do we do that? For finding the sum of odd factors, again I am taking this example 24. Now this 24 is 2 raised to the power 3 into 3 raised to the power 1. As I have told this earlier also, for finding the number of odd factors, we always have to eliminate all the 2's. That is, whatever number of 2's are there, you just have to eliminate them. So what I can do, I can simply eliminate all these 2's, and whatever power is there, you just add 1 in it. So I can say that there are 2 odd factors, but as we have to find the sum of those 2 odd factors, so I can write this 3 raised to the power 1 as 3 raised to the power 0 plus 3 raised to the power 1. So this can be written as 1 plus 3. So this will be equal to 4. So sum of all odd factors of 24 will be equal to 4. Let us take another example in this. Let us talk about this 36. Now this is 2 square multiplied by 3 square. Now again, as I have to find the sum of all odd factors, I have to eliminate all these 2's, because 2 multiplied with an odd number will always gives us an even number, and we don't want even number over here. So this 3 square can be written as 3 raised to the power 0 plus 3 raised to the power 1 plus 3 raised to the power 2. So this can be written as 1 plus 3 plus 9. So we can say that the sum of all the odd factors of 36 are 13. Sum of all the odd factors of 36 is 13. So this is how we find the sum of all the factors of any kind of number. Now there can be questions that can be asked in different format also. The question can also be asked in this way: finding the factors that are square. That is, finding the square factors of any number. For example, if I talk about this number, let us say 24. Now this is 2 raised to the power 3 into 3 raised to the power 1. I can again write this number as 2 raised to the power 0 plus 2 plus 3. And I can write this 3 raised to the power 1 as 3 raised to the power 0 plus 3 raised to the power 1. If I write the respective values of this, of all these numbers, I can write them as now if we see clearly, we can say that 1 is always the square, 1 is the number that is always intact. Whether you do its square or you do its cube or you do its any power, 1 always remains same. So I can say 1 can always be the square or it can always be the cube. So if we have to find the number of factors that are square, so I can say 1 will always be there. Similarly, there is this number 4. This is also the square factor, or I can say this is the square of 2. So we have 2 factors here that are square. Now again I can say that there is one more number, that is 1. Now this is again the square. So we have 2 factors from here and we have 1 factor from here, and if I multiply them, I get this 2. So I can say there are 2 factors overall. Let us take one more example. If I am talking about this 36, now this 36 can be written as 2 square multiplied by 3 square. Now this 2 square again can be written as, and this 3 square can be written as. Now if I'm writing the respective values, then I can write them like this. Now again, as I told you, 1 is always the square of cube or cube, so 1 will always be there. Now 4 is the square of 2, again this 1 is there, and then this 9 is there. So I can say that 2 factors we got from here and 2 factors we got from here. So overall there are 4 factors that are the square factors or that are squares in the case of 36. Let us take one more example in this one. If I am talking about a number, let us say 1080. Now I can write this number directly as 2 raised to the power 3 into 3 raised to the power 3 into 5 raised to the power 1. Now if I have to find the number of square factors, I can write this one as now you just have to spot the numbers that are squares. That is, that are squares, or we can say that are the multiples of 2. So I can say this 2 raised to the power 0 gives us 1, so this will always be there. Then 2 raised to the power 2, 2 is the square. Then again 3 raised to the power 0, and then again 3 square, and then again 5 raised to the power 0. So I can say I have 2 numbers from these ones, then I got 2 numbers from this one, and then I get 1 number from this one. So I can say there are 4 numbers or 4 square factors of 1080. Now what is the easier way to solve these kind of questions, or how we can easily solve these questions? The easier way to solve these questions is, whenever we get any such kind of factors? What we have to do, as we know that all these A, B and C are primes here, and P, Q and R are their respective powers. So what we can do, you just simply divide these powers by square and then simply add 1 in it. Simply dividing these powers by 2 and then adding 1 in it. Remember this, whenever you have to find the square factors, or you have to find the sum of all the factors, or you have to find the even factors, or you have to find the total number of factors, you always have to remember one thing, that 1 is always added in the powers. So if I am dividing the powers by 2, as you can see that P is 3 over here, so dividing this 3 by 2 plus 1. Now Q is again 3 here, dividing this 3 by 2 plus 1, and then R is 1 over here. So we can write this one as 1 by 2 plus 1. Now we just have to divide this 3 by 2. We don't have to write the decimal. We have to see till wherever it can be divided. So 3 to 1 time is 2 and the remainder will be 1. So I just have to write it 1 time. 2 1 time is 2 plus 1. 2 again 1 time is 2 plus 1. Now 1 is not divisible by 2, so you don't have to write anything. So let's simply write this one. Now this is 2 multiplied 2, that is equal to 4. So I can say there are 4 factors that are the square factors of 1080. Now this is the another question that can also be asked, finding the factors that are cube. Now if we have to find the factors that are cube, again we have to do the same thing. What we have to do, suppose I am taking the example of this number 36. Now this 36 can be written as 2 raised to the power 2 into 3 raised to the power 2. We can write this number as now what we have to do, we have to see the cubical factors in this, or we have to see the powers that are 3 or the factors of 3. As you can see this, that none of these powers are divisible by 3 or the factors of 3. So we can just simply say that 2 raised to the power 0 will give us 1, and 1 square or 1 cube is always a factor. Similarly 3 raised to the power 0 will give us 1, and 1 multiplied with 1 will give us 2. So we can say, 1 multiplied with 1 will give us 1. So we can say that there is only one factor in 36, that is a cube. Now what else we can do? We can write it in the form like this, and what we can do, we can simply divide this P by 3 plus 1, again Q by 3 plus 1. Now this P here is 2 by 3 plus 1, and this Q here is 2 by 3 plus 1. So as 2 is not divisible by 3, so this is 1, this is also 1. We get this, only one factor is there in 36, that is a perfect cube. Well, now this another type is how to find the reciprocal of sum of all factors. Now this can also be the possible type on which questions can be asked in the exam. So how do we solve such kind of questions? Now again I am taking this simple example. I am taking the case of this number 24. Now as we know that the factors of 24 are, I can write this one as 2 raised to the power 3 into 3 raised to the power 1. Now if I write all the factors of 24, I can say that 1, 2, 3, 4, 6, 8, 12 and 24. I can say these are all the factors of 24. Now if I have to find the reciprocal of all these factors and then I have to find the sum, what I have to do is I simply have to do their reciprocal like this, 1 by 1 plus 1 by 2, and then adding all of them. Now as you can see that the LCM of all these numbers will be 24. Now dividing this 24 by 1, I get this 24 plus this 2 12 times, this is 3 8 times, 6 plus 4 plus 3 plus 2 plus 1. And then if I add all of them, then you will see that this is eventually the sum of all the factors. These are all the factors of 24: 24, 12, 8, 6, 4, 3, 2, 1. We know that there are 8 factors of 24, and these are all those factors. So I can make a formula out of it, and then I can say that for finding the reciprocal of sum of all factors, the formula is sum of all factors divide by that number. So this is how we find the sum of all the factors, and we know how to find the sum. We can just simply write down the factors and then we can simply add them. So if I have to find the sum of all the factors by using this formula, what I can do, I can write this to raised to the power 3 as and then I can write this 3 raised to the power 1 as divide by that number, that is 24. Then again I can write this one as so I can say this will be the sum, the reciprocal of the sum of all factors of 24. So this is how we get the answer. We just have to remember this formula. Now this formula is an important one. Now this, I can say that this topic is important. Many a times such kind of question has been asked in the examination. Let us see another example in this. Now let us take another example in this one. Let us say that the question is 36 and I have to find the reciprocal sum of reciprocal of all factors. Sum of reciprocal of all factors. Now how we can do that? Again, this 36 can be written as 3 square multiplied by 2 square, and then according to the formula is sum of all the factors divide by that number. Now what will be the sum? Sum will be equal to, I can write this one as expanding the powers, so we can say the answer of this one is 91 divided by 36. I can say this is the reciprocal of sum of reciprocal of all factors of 36. So this is how we find the reciprocal and then sum of all the factors. Finding the sum of all perfect squares. If I have to find the sum of all the perfect squares of any number, then what is the method of doing it? Again, the method is same whether you have to find the factors, simple factors, or we have to find the sum of the perfect squares. Again, I am taking the example of this simple number 24. I can write this one as now 2 raised to the power 3 can be written as Now if you see this, how many factors we are getting here that are the perfect squares? As I have told you earlier also, that 1 is always the perfect square or 1 is always the perfect cube, because 1 remains as it is. So 1 will be there. Then 4 is also the perfect square. Similarly, again 1 is over here. So we have 2 factors in this one and 1 factor in this. So if I have to find the sum of all these factors, that are perfect squares, so I can say this 4 plus 1 is 5 and this 1 is over there. So I can say that the sum of all the factors that are perfect squares is 5. How we got this 5? I know that in 24 there is a number that is 4 and 4 is the perfect square. Then there is another number 1 is also a perfect square. Now I cannot take 9 because 9 is not the factor of 24. So we have only 2 factors, 4 and 1, and the sum of these 2 factors is equal to 5. Let us take another example in this. I am taking the case of 36. If I have to find the factors that are perfect squares and I have to find the sum of them, I can write this number as 2 square multiplied by 3 square. Again this number can be written as Now again we can see this, that how many perfect squares we are getting. As you can see, this 1 is always the perfect square. Now this 4 is also the perfect square. Again this 1 is over here, and again this 9 is over here. So if I add them, I get this 5, I get this 9 plus 1 10, I get the answer as 50. So I can say if I have to find the numbers, if I have to find the sum of the perfect squares, then the answer will be equal to 50. Now let us see this another type, finding the sum of perfect cubes. Now we have solved the questions in which we have to find the numbers which are perfect cubes of any number. But how do we find the sum of perfect cubes? How do we find the sum of all those perfect cubes? Now, what is the way of doing this? So solving such kind of questions, I am taking an example. Let us say, let us take any number. Let us say the number is 216, and I have to find the sum of all the cubes of this number. So first of all I have to factorize it, and I can say that this number can be written as now this number can be written as 2 raised to the power 3 multiplied by 3 raised to the power 3. Again expanding this number, I can write this one as now as we have to find the sum of perfect cubes. So first of all I have to see how many perfect cubes are there in this number. So for finding the perfect cubes, you can see 1 is always the number which is a perfect square or it is a perfect cube. Similarly 8 is the number, then 1 is the number which is a perfect cube, and again 27 is a number which is a perfect cube. So I can simply add these numbers, 1 plus 8, and then I can write this one as 1 plus 27. So this will be equal to, this is 9 and this is 28. So multiplying 9 28 times is 9 8 72, 9 2 18, and 18 7 is 25. So I can say the number of factors, I can say the number of factors, number of perfect cubes, their sum is equal to 252. So in 216, whatever factors are there which are perfect cubes, then their sum will always be their sum will be equal to 252. So this is how we find the sum of perfect cubes. So the method is simple. We just have to see the cubes given to us, or we can say we have to see the powers which are the multiples of 3. As this is 3, this is the number, then this 3 raised to the power 0, and then this is the multiple of 3. You just have to identify those numbers. You have to write their respective values, simply add them and multiply them. You will get the simple answer. So this is how we find the sum of the perfect cubes of any numbers. Now another kind of questions that can be asked in this one is miscellaneous kind of questions. Now these are the exact types I have told you that comes in the exam. Apart from them, you also have to remember some miscellaneous questions. For example, find the factors of 36 which are multiple of 3. Now how do we find the factors of 36 which are multiple of 3? How we have to do that? Now let us do it manually just by expanding all the factors. 36 can be written as 2 square multiplied by 3 square. Now expanding again these numbers. Now if I multiply all of them, I am multiplying this one with all these factors. I get 1 plus 3 plus 9. Multiplying 2 with all these factors, I get 2 plus 6 plus 18. And then multiplying 4 with all of these factors, 4 plus 12 plus 36. Now as the question is, we have to find the factors which are the multiples of 3. Now if you see, I can say that this 3 is the multiple of 3, 9 is also the multiple of 3, then there's the 6, then 18, 12 and then 36. I can say we have 1, 2, 3, 4, 5, 6. 6 factors which are the multiple of 3. We have 6 factors which are multiple of 3. Now this is the manual way of solving the question. But we don't, if the number is large, if the number is of 3 digits or 4 digits, every time manually we cannot do this. It's not even possible. Now, what is the another way of doing this? What we can do, if I have to find the multiple of 3, I know that these are the factors 2 square into 3 square of number 36. If I have to find the multiples of 3, what I do, multiple of 3 means I have to take 3 common from it. If I take 3 common from it, what I got is, I got 2 square multiplied by 3 raised to the power 1. Now whatever is left inside the bracket, after taking the desired number common, if you take the desired number common, whatever is left inside, you have to follow the same process as we follow in finding the number of factors. That is, we simply have to add 1 in their respective powers and then multiply them. I can say this 2 plus 1 and then this is 1 plus 1. So this is equal to 3 multiplied 2, that is 6. So I can say that there are total 6 factors which are the multiple of 3 in case of 36. Let us take one more example in this. Let us say the number is 1080 and I have to find the factors which are multiple of 9. I have to find the factors which are multiple of 9. Now how we can do this? If I have to find the factors which are multiple of 9 in case of 1080, first of all, factorizing this number, I can write this 1080 as Now as the question is based on finding the factors that are multiples of 9, so I can say that 9 means 3 square. So what I have to do, I have to take 3 square common out of all these factors. Now the numbers remaining inside is 2 cube multiply 3 raised to the power 1 multiply by 5 raised to the power 1. Now taking out common, we don't have to include the power of this number. Whatever is left inside, you just have to include the powers of those numbers. So the 2 raised to the power 3, so I can say 3 plus 1, 3 raised to the power 1, 1 plus 1, 5 raised to the power 1, 1 plus 1. So this is equal to 16. So I can say there are total 16 factors that are multiple of 9 in case of 1080. So such kind of questions can also be asked in the questions related to factors.